Hello students, let us learn today how to calculate the valency of elements. In the last part of the video, I shall be explaining the definition of valency. Let us do the calculation first. It will be easier to define valency towards the end. Alright. So everything starts with atomic number. Let us take an example of, let's take an element, suppose sodium. Okay, sodium. What is the symbol of sodium? Sodium has a symbol of Na. Okay. Now atomic number, I have to write all the parts here. So atomic number of sodium is 11. Okay. So its electronic configuration, I have already discussed about electronic configuration in the previous video. So electronic configuration of sodium, because atomic number is 11, so it will be 2, 8, 1. Okay. 2, 8, 1. And what are those 2, 8, 1? That is electronic configuration. That means arrangement of electrons. So now 2, 8, 1. How many electrons in the last cell? 1. This last cell is also called the valence cell. These are all concepts in chemistry. Okay. Now sodium has two options. One, it can take 7 electrons from somebody and can become 2, 8, 8. Or if it releases 1 electron, it will become 2, 8. Now you must be wondering why it should do that. Okay, for that little background knowledge is required. This 2, 8, 1 is an unstable configuration. Why it is unstable? Because if you remember the rule, first cell should contain maximum 2, second cell should contain maximum 8, like that. Okay, so the third cell is not stable over here because it is only 1 over here. So it wants to attain stable configuration. This statement is very important. All the elements, all the atoms, they try to attain the stable configuration. Okay, so come back to the story now. Here if you look at this, if you take 7 electron from somebody, it will become 2, 8, 8, which is a stable configuration. Similarly, if it releases 1 electron, and it will become 2, 8, which is also a stable electronic configuration. Now my question is, sodium is going to do this one or this one? Which is easier energy wise? To accept 7 from somebody or to release electron? Obviously this is easier, isn't it? So sodium is going to do this, and that is why how many electrons it will lose? 1. That is why the valency of sodium is 1. Okay, let me take one more element so that you understand. Let's take the example of nitrogen. What is the symbol of nitrogen? N. What is the atomic number of nitrogen? 7. So what is the electronic configuration? 2, 5. So it obviously wants to become stable, right? 2, 8 suppose. So it has two options. What it can do? It can take 3 from somebody and can become 2, 8, or it can release this 5 and can become 2 only. Okay, which option it is going to do? Obviously energy wise, which is more plausible or which is more feasible? Obviously to take 3 from somebody and become 2, 8. So nitrogen is going to do this, isn't it? So the valency of nitrogen is 3. Keep in mind this plus 3, minus 3, the sign, the plus and minus, the signs won't come in while calculating valency. It is all about the number of electrons. Okay, last one quickly, let's do one more. Suppose let's say aluminium. Okay, atomic number is 13, electronic configuration is 2, 8, 3. What is it going to do? Release 3 so that it become 2, 8. This is one possibility. Or take 5 from somebody, become 2, 8, this is another possibility. Which one it is going to do? Obviously it is going to do this. So what is the valency of aluminium then? 3, not minus 3. Okay, so this is how you're going to calculate valency. It's all about understanding what an element or what the atom of the element is going to do to become stable, and that is why valency, remember I told you I'll define it at the end. So valency is defined as the combining capacity of an element. Okay, for example, let's say neon. What is the symbol of neon? Ne. What is the atomic number? 10. So let's say electronic configuration is 2,8. What it is going to do to become stable? Nothing, because it is already stable, isn't it? 2,8 is already a stable configuration. So what is its combining capacity? Its combining capacity is 0. It doesn't need to combine. So what is the valency of neon? The valency of neon is 0. Okay, so if you have understood the concept, please try to gain all the valencies, calculate all the valencies from hydrogen to potassium, that is 1 to 20. At least for first 20 elements you should be knowing all the valencies. All right, in the next video we shall be learning a very interesting concept, that is called variable valency. Some elements like iron, oxygen, nitrogen, they have more than one valency, right? Valency can be 3, valency can be 5, like that, right? So in the next video we shall be discussing about that, and we'll also discuss the reason for some elements having variable valency.